behind it. All right, so your linear systems and matrices, the first section, though, is just solving systems of equations. And you've done this before, but there's a couple more complex systems that we'll work on in this section. The first way, though, that we're going to solve systems is using substitution, which you're probably going to be familiar with and feel like you've already done this. So we'll just quick zip through it. But here is kind of the methods for solving systems using substitution, where you solve one of your equations for one of your variables, and then you substitute that into the other equation and solve for the remaining variable, and then you have to go back and substitute back in to find the other variable. So if we look at this first system, if we're using substitution, what we're going to do is solve one of these equations for a variable and substitute it into the other equation. So if I look at this second equation, if I solve this second equation for x, then I would have that x equals 2 plus y. And then I'm going to take that 2 plus y and substitute it into the x in my other equation. So I'll have 2 plus y equals 4. If we start simplifying, you get 2 plus 2y equals 4. So 2y equals 2, which means that y equals 1. And because we're finding a solution to a system, we have two lines right here. So what we're looking for is the point where they intersect. So we have the y coordinate where they intersect. And then what we're going to do is plug the 1 back in for our y and solve for our x. So x equals 2 plus 1, which means x equals 3. And so the solution to the system, or the point where these two lines would intersect, is at the point 3, 1. All right, so now let's apply this to a real life application. You have $25,000, and you're going to invest this into two different accounts. One pays 7% and one pays 4%. Or you already did that. And then the interest that you earned in the year was $1,405. So we need to figure out how much did you invest into each account. So the first thing you have to do with story problems is figure out what are your variables going to be. So what are the two things in this case that they're comparing? And they're comparing the 7% account and the 4% account. So our variables are going to be the accounts. And let's call those A and B. So we need to write two equations that both use the variables A and B. So your two equations you're going to have a total amount. So what is the total amount invested? And so in that case, we know that if we add A plus B, we have a total amount of $25,000. And then we're going to write our interest equation, because those are kind of the two pieces of information they gave us. How much did we invest and how much interest did you earn? So if we say that 7% is the interest on the A account, then we know that 0.07 times A, so 7% interest on what you put into A, plus 4% interest on what you put into B, earned a total of $1,405 of interest. And so now if you use substitution to figure out how much is invested, you probably first want to think about which equation would be easier to solve for a variable. And hopefully you think the first one. And it doesn't matter which variable you solve for. So if we take the first equation and we solve for A, we know that A equals 25,000 minus B. And so we'll take that A value, that 25,000 minus B, and we'll plug it into the A in our second equation. So we'll have 0.07, but instead of A, we're going to substitute 25,000 minus B plus 0.04B equals 1405. And now you just have an algebra problem. You have to solve for B. So we have to distribute the 0.07 through. So if we do 25,000 times 0.07, we get 1750 minus 0.07B plus 0.04B equals 1405. Combine your like terms. So 1750 minus 0.03B equals 1405. If you subtract 750 from both sides, you get negative 345. And then if you divide that by negative 0.03, you get that your B equals $11,500. So that's how much was invested into your B. And then remember, you're just going to substitute that back into your equation and solve for A. So A will equal 25,000 minus 11,500. So A is 13,500. All right, so our next problem is looking at a system of equations that they're not both linear. So this first equation is actually quadratic. So this first equation is a parabola, and the second equation ends up being a line. And we're going to find the two places in this case that these equations intersect using substitution. So when you look at your equations, it's probably going to be easiest to substitute into the first equation rather than to solve the first equation for x. So if I solve the second equation for y, I could say y equals negative 2 plus x. And then I'm going to take that negative 2 plus x and substitute it into the first equation for y. So I get 3x squared minus 2x minus 2 plus x equals 0. And if you combine like terms, we get 3x squared minus x minus 2 equals 0. So the good news in this chapter is that we don't have the unit circle. But the bad news is we've gone back to factoring. So here, in order to solve for x, we have to factor 3x squared minus x minus 2. So we'll factor into 3x plus 2 times x minus 1. And if we set each factor equal to 0, we get x equals negative 2/3 and x equals 1. And so those are your two x coordinates for your solutions. So if we're looking at the solutions, one of the solutions will be negative 2/3, comma, something. We have to solve for that y. And the other solution will be when x is 1, and we have to solve for that y. And so again, once you have those x coordinates, we're going to substitute them back into x to solve for y. So if we plug in the negative 2/3, we get y equals negative 2 minus 2/3. Or y equals negative 6/3 minus 2/3, which is negative 8/3. So your y coordinate is negative 8/3 when your x coordinate is negative 2/3. And then we do the same thing when x is 1. We say y equals negative 2 plus 1. So we get y equals negative 1. So negative 1 would be that y coordinate. And then those 2 points would be, if you were to graph it, those 2 points would be those 2 points up here where that line intersects your parabola. So another way to solve your systems of equations is to graph. And in order to graph them, both of your equations need to be in y equals form. And then you plug them into your calculator. So when we look at this system here, in order to graph these, we could graph in our y1, we could plug in x squared, right? Because that's already in y equals form. But this equation right here is not in y equals form, which means we need to solve it for y. So if we start solving for y, we could say y squared equals 10 minus x squared. And then remember, when you take the square root of both sides, you need a plus or a minus square root. So what happens then is when you graph this, in your y2, you're going to plug in the square root of 10 minus x squared. And in your y3, you're going to plug in the negative square root of 10 minus x squared. And you end up getting a graph that looks like a circle and then a parabola is what happens. So we're looking for these 2 points of intersection right there. So take a minute and graph those and see if you can figure out what those 2 points are of intersection from your graph. And so that first intersection point we get is at what? Negative 1.64. And the y coordinate is 2.7. And then what you end up finding out when you do that other one is it's just that reflection over the y-axis. So it's at positive 1.64 and positive 2.7. All right, and then the last thing we're going to talk about is the break-even point. So when you get to problems that ask you where the break-even point, the break-even point is when the revenue equals the cost. So to find your break-even point, you're going to have to find a revenue equation and set it equal to a cost equation. Revenue is the total amount of money you bring in. So your total money earned. It's different than profit because with profit, you take out the cost. So revenue is like if you sell candy bars for $2 and you sell 10 candy bars, your revenue is $20. But your profit might only be 10 if it costs you $1 a candy bar yourself. So revenue is just your total, and then cost is what it costs to make it. All right, so we have a small business that invests $10,000 in equipment to produce a new soft drink. Each bottle of the soft drink costs 65 cents to produce and is sold for $1.20. How many bottles must be sold before the business breaks even? So let's figure out, right, we need a revenue equation. And we need to set it equal to our cost equation. So revenue is the total income you're going to bring in. So in this case, the only money that's brought in is the $1.20 that each bottle is selling for. All right, so our revenue will be $1.20 or 1.2 per bottle. And our cost is $10,000 plus 65 cents per bottle. And so we need to figure out when those are equal. So we need to figure out how many bottles need to be produced in order for the revenue to be higher than your cost or then to break even. So if we subtract 0.65b, we get 0.55b equals 10,000. And if you do 10,000 divided by 0.55, you get that B is 18,181.82. But you have to think if it makes sense to make a partial bottle of soft drink. Like you're not going to make part of a soft bottle or sell part of a bottle, right? So in order for that revenue to be a little, you probably want your revenue to be a little bit higher than your cost. In this case, we'll round up one more bottle. And so we'll say that you need to produce 18,182 bottles. So for some of these problems, you need to think about, does it make sense to have a portion of the product, or do you really probably need to have a whole product?